Reading Comprehension, C1-C2, Lesson 11, The Future of Renewable Energy, Challenges, Innovations, and Global Impact. Let's begin.
The global energy landscape is undergoing a profound transformation as countries, industries, and individuals increasingly turn to renewable energy sources to combat climate change, reduce pollution, and decrease dependence on fossil fuels. Renewable energy, derived from sources like wind, solar, hydropower, and geothermal, is seen as the cornerstone of a sustainable future. As the world grapples with the environmental and economic consequences of fossil fuel consumption, the push toward renewable energy is accelerating, with technological innovations, policy shifts, and public awareness driving the transition. However, significant challenges remain in the path toward a fully renewable energy system, and the future of renewable energy will depend on how effectively these challenges are addressed. One of the primary drivers of the shift to renewable energy is the urgent need to mitigate the impacts of climate change. The burning of coal, oil, and natural gas releases vast amounts of carbon dioxide, CO2, into the atmosphere, contributing to the warming of the planet. In contrast, renewable energy sources produce little to no greenhouse gas emissions. Solar panels, wind turbines, and hydroelectric dams generate electricity without releasing pollutants that contribute to global warming, making them a crucial component of efforts to limit temperature increases to below 1.5 degrees Celsius, as outlined in the Paris Agreement. Solar energy, in particular, has become one of the fastest-growing sources of electricity. The development of photovoltaic (PV) technology, which converts sunlight into electricity, has advanced rapidly, with the cost of solar panels plummeting in recent years. Large-scale solar farms are now providing energy to millions of homes and businesses around the world, while decentralized systems, such as rooftop solar panels, are allowing individual households to generate their own power. Innovations in energy storage, such as more efficient batteries, are addressing the intermittency problem of solar power, enabling excess energy to be stored and used during times when the sun isn't shining. Wind energy is another key player in the renewable energy revolution. Wind turbines, which convert the kinetic energy of the wind into electricity, are being deployed onshore and offshore in ever-increasing numbers. Offshore wind farms, in particular, are proving to be highly effective, as wind speeds are typically stronger and more consistent at sea than on land. Countries with long coastlines, such as the United Kingdom, Denmark, and China, have invested heavily in offshore wind projects, and floating wind farms, which can be deployed in deeper waters, are becoming a promising frontier for the industry. However, despite the growth of renewable energy, there are still significant challenges that must be overcome to fully transition to a clean energy future. One of the most pressing issues is the intermittent nature of wind and solar power, as their output fluctuates depending on weather conditions. Energy storage technologies, such as lithium-ion batteries and emerging alternatives like solid-state batteries or green hydrogen, are crucial for overcoming these fluctuations and ensuring a reliable power supply. Additionally, modernizing the electrical grid to accommodate distributed and variable energy sources is essential for the large-scale deployment of renewables. Another challenge is the geopolitical and economic implications of a transition to renewable energy. While renewable energy is often praised for its ability to reduce dependence on fossil fuels, the minerals required to manufacture wind turbines, solar panels, and batteries, such as lithium, cobalt, and rare earth elements, are largely concentrated in a few countries. This has raised concerns about supply chain vulnerabilities and the potential for new geopolitical conflicts over access to these critical materials. Moreover, the shift to renewable energy could disrupt industries and economies that are heavily dependent on fossil fuel production, leading to job losses and economic hardship in regions that rely on coal, oil, and gas. Despite these obstacles, many countries and organizations are making ambitious commitments to renewable energy. The European Union, for example, has set a goal of achieving climate neutrality by 2050, with renewable energy expected to play a central role in eliminating carbon emissions. In the United States, the Biden administration has introduced initiatives aimed at accelerating the transition to clean energy, including massive investments in wind, solar, and energy storage projects. Meanwhile, China, the world's largest emitter of greenhouse gases, has become a global leader in renewable energy deployment, particularly in the solar and wind sectors, and aims to achieve carbon neutrality by 2060. Innovation will continue to drive the renewable energy revolution. Breakthroughs in energy efficiency, grid management, and new renewable technologies, such as wave and tidal energy, could unlock even more potential for clean power. In addition, advances in artificial intelligence (AI) and machine learning are helping to optimize energy production and consumption, allowing for smarter energy grids and more efficient use of resources. Looking ahead, the future of renewable energy is undoubtedly bright, but its success will depend on global cooperation, political will, and continued investment in research and infrastructure. A just transition to renewable energy must also consider the social and economic implications of phasing out fossil fuels, ensuring that vulnerable communities and workers in fossil fuel-dependent industries are supported. With the right policies and technologies in place, renewable energy has the potential to transform the global energy system and pave the way for a cleaner, more sustainable future.
Thanks for watching. Visit www.TutorUKABC.com for more fun learning material.